Hi, everyone. Welcome to our April webinar. My name is Lisa, and Jordan, as you can see on the screen, is also here, and we are occupational hygienists at T. Harris Environmental Management. Today, we will be discussing the topic of indoor environmental quality, and hopefully everyone's here. I actually see a couple people coming in, so maybe we'll wait another minute before we start so that everyone has the opportunity to come in. But we'll be kind of having like a panel discussion, so we'll just do presentations for now, and then at the end, if you have any questions, please save them, and like the last 15-20 minutes we'll reserve for questions, which if they pop up throughout as we're presenting, have them in the chat, or at the end we can unmute you if you want to say them over the mic instead. But yeah, I guess we can start now. So as I said before, the topic we'll be discussing today is indoor environmental quality. So what is indoor environmental quality exactly? Well, indoor environmental quality, also known as IEQ, is a holistic approach to monitoring and controlling the quality of a building's indoor environment related to the health, well-being, and productivity of the occupants within it. So why is IEQ important? Well, recognizing the early signs and symptoms of poor IEQ can help prevent more serious conditions from developing. So some of these more serious conditions that may result from poor IEQ include building-related illness or sick building syndrome. And these are illnesses that people experience while within the building that they are occupying. And as well, there are health effects such as musculoskeletal diseases, and these include things like bad backs, carpal tunnel syndrome, and more ergonomics related conditions. And then lastly, poor IEQ can also lead to psychosocial diseases, and these are things such as stress that people may experience while within an indoor environment. So in IEQ, we consider the indoor environment as a system, and so we look at it as a whole. Typically, when people hear about like the quality of an indoor environment, they automatically think of indoor air quality, but it's important to consider that the indoor environment encompasses more than just the air that we breathe while we're in a space. It also includes things like the physical office layout, the office environment, and what workers may be doing within this environment. So in an indoor environmental quality assessment, we will assess all these different components, and we'll be touching on these throughout today's webinar. So as I mentioned before, indoor air quality is one component of the indoor environment. And as a quick definition, indoor air quality is the quality of, well, the air within and around buildings and structures, especially as it relates to the health and comfort of building occupants. And there are two main components of indoor air quality, and those are thermal comfort, so the temperature, and the relative humidity, which describes how wet or dry the air is. And as well, the second component is indoor pollutants. And we will I'll be describing the indoor pollutants in more detail, since that's something that isn't as intuitive as the temperature and humidity. So indoor pollutants are very common in a building and can come from many sources. So for example, in a typical office building, we may have workers who wear perfumes or colognes and fragrances to work, and fragrances can be an indoor pollutant. We may also have plants in our office, and plants can contribute to allergens and molds, especially if they're poorly maintained. We also have printers which emit ozone, and new flooring can also emit formaldehyde. So it's important to note that just because these indoor pollutants exist doesn't necessarily mean that they will be released at levels that cause discomfort. So here is a list of common indoor pollutants and their sources. I already spoke about a couple of them, but to just go over the list, there's carbon monoxide, which can come from space heaters and furnaces. Formaldehyde, which I said before, can come from building materials, and it can also come from wood furniture because of the finishings that the furniture may have. Fungi and mold can come from spoiled food, plants, as well as water damage if the structure of the building has leaks. Nitrogen dioxide can again come from space heaters and furnaces. Ozones can come from printers, photocopiers, as well as air purification devices, which use ozone as a disinfection technique. Particulate matter can come from space heaters, cigarette smoke, as well as the outdoors as air is coming in. If it's not filtered, it can be a source of particulate matter. And lastly, there's volatile organic compounds, which can come from many, many different sources, including paints, air fresheners, and perfumes. So issues that may arise from poor indoor air quality include health issues such as dryness and irritation of the eyes, nose, and throat, headaches, dizziness, fatigue, and allergies. And these can result from a single or repeated exposure, and these are more immediate health effects. For these immediate health effects, people generally notice that there are symptoms at work, and they feel better when they leave the building or when they have been away from the building for a weekend or a long vacation. So after an extended break, people might feel like they feel better. And in terms of long-term health effects, these are less common, and they include respiratory diseases, heart disease, and cancer. There are also issues that arise that aren't health-related, and these include absenteeism. So people not showing up to work because of poor indoor air quality also applies to, in general, indoor environmental quality. So people might not show up to work. People might have a loss of productivity as well. This can lead to strained relationships between employers, workers, and or building management. And this ties into the psychosocial aspect of having good IEQ that I discussed earlier. So indoor air quality is mainly controlled by the building's HVAC system. And so just in short, the HVAC system is responsible for bringing in outdoor air, filtering it, heating it, and conditioning it to the right temperature and relative humidity, then dispersing the air throughout the occupied space. In terms of how to improve indoor air quality, one of the things we can do is just to maintain general cleanliness. So making sure that we remove garbage frequently, storing food properly, as well as cleaning out the fridge regularly so that we don't have months-old food in the back of the fridge, as well as maintaining the indoor plants. So if you do have plants in your office, perhaps making sure that they're not overwatered, for example, and that they're generally healthy. And this can reduce the amount of pollutants that they release. You can have regular maintenance of the HVAC system. So this involves changing the filters, inspecting the components, as well as clearing debris in and around the unit. And lastly, one way to improve IAQ would be to upgrade the HVAC system if your inspection has identified the need to. And so tracer gas assessments, which I'll be talking about later on, is one way that we can assess the ventilation and identify the need for upgrades. And in terms of indoor air quality standards, here are a bunch of standards in case you were interested in what acceptable indoor air quality is. As well, indoor air quality is important for certain certifications such as LEED and BOMA BEST, which have kind of criteria for what the air quality should be in the space to be certified.
So now we'll be talking about the physical office environment. So Lisa mentioned the air, and now the second part of the indoor environmental quality would be the physical components. So that's pretty much the what. So what we can see, what we can hear, what we can feel, pretty much the lighting, noise, and ergonomics. All of this can be lumped into one pretty much. It can just be ergonomics. But at the same time, when you think of the word ergonomics, you don't think of noise and lighting. You just think of how an office is designed or how a chair is and that sort of thing. But in reality, according to the CSA standards, lighting and noise are combined with ergonomics, but I felt like it would be appropriate to separate the three so that we can talk about them and give them all their deserved attention. So when would you be doing assessments for the physical environment? You can do it following your, okay, for example, let's say you conduct IAQs on an annual basis. You can lump this into that IAQ program and create an IEQ program. So you have annual IEQs, and those can be done not all at the same time, but let's say you do an IAQ in March, you do a ventilation assessment in September, then you can do your physical pollutants, some other times throughout the year. And that way you can create a record and you can see how things change over the years. And let's say you do change the physical environment, you can see, was that a positive change or was that a negative change? And that's going to lead my way into why these physical pollutants are important. And that's the next slide here. So why? Just like traditional IAQ pollutants, the physical pollutants greatly affect the occupant's health, well-being, and productivity. And it's funny, so like in our experiences with IAQs, we noticed as we're going around that some indoor environmental pollutants are often forgotten. And usually some indoor air quality ones are forgotten, but most of the times it's physical pollutants that are forgotten. And one time I brought this up with someone on site and they told me that this quote here. So they said, it's there, we can see it. So it's not that bad for us because we can see it's there. Unlike the air, we can't really see the air. And I kind of chuckled at it because, yeah, you can see it's there. Just like how lighting is always present in an office environment. Lighting being present is not the issue. It's certain levels of lighting that is required to perform tasks effectively and efficiently that might be the issue. So for example, if lighting is too much or too little, if it's in the wrong direction, it could even be creating shadows or glares. And having these, wrong scenarios can reduce the occupant's comfort and ultimately their productivity at work. So let's look here at this short clip about an office. We have potential issues with glare here. You can see it on the left-hand side. If you look at the top, those 3 rows of desks, you can see the glare coming off the floor. And then if you really look closely, you'll see glare coming off the desks. And those people might have issues with that. And that's one thing that might be assessed. The indoor air quality there might be good, but now other things are starting to impact their comfort and productivity. So that's something that should be considered. And another thing is noise. So this is open concept design. And you can see people are getting up, walking around, talking in groups. So that's something that might be considered, is how much noise is being produced within the indoor environment there. So this is the same office, but a different view. And we can see right away, just by looking at it, that the physical environment is different, just looking at it from another angle. We can see that there's shadows or pretty much a darker area on the top floor and underneath the top floor, so on the bottom floor. Whereas in the other view, it looked nice and bright and full of light, but on the other side, it's dark. So this can impact the working conditions and their productivity, even though during an indoor air quality assessment, the air quality throughout the office space might be similar, so all is well. But now the physical environment, it should be considered because we can visually see that it's different. And we might be lucky where it is good, but we also might be unlucky where those conditions aren't appropriate for the tasks being performed. And I'll talk about how that's determined later. So let's review. With an IEQ assessment, like Lisa said, we use a holistic approach. And then what we're doing is pretty much assessing the indoor environment system. So we're looking at it all as a whole, and we can pretty much split it into 2 main branches, which is Lisa's indoor air quality, and that has, like what she mentioned, chemicals, mold, bacteria, thermal comfort, and then also ventilation assessments using tracer gas. And then we can break it down into another branch, so the physical environment pollutant. So that's ergonomics is the main thing, but then we like to split it down into noise and lighting because those are very important also. So that will lead me into talking more about the physical environment pollutants. And just recapping what they are is pretty much what you can see, hear, and feel. And that's ergonomics, noise, and lighting. They're all related, like this diagram shows. It's pretty much a continuous loop of one impacts the other. So that's why it's important to assess all of them rather than just assessing one thing and using it a holistic approach. So going into why and why is it beneficial? So the outcomes of well-controlled physical environment pollutants. So when all is well and everything is meeting its guidelines, you'll see typically a reduction in cost for musculoskeletal injury claims. So your WSIB premiums, the amount of WSIB claims for, let's say, carpal tunnel, back pain, headaches, that sort of thing. And then you'll also have workers basically saying and talking about how they're suffering from less pain and they're not feeling as tired. And in one study, that dropped 42%. So that's pretty significant that 42% of the workers reported less pain and less fatigue when an ergonomics intervention was performed, a lighting assessment was performed, or a noise assessment was performed. And then what other employers and even this employer consistently report is that when physical environment pollutant assessments are conducted, they see increases in productivity, quality of the work being performed, and the employee morale increases. So when you're doing the frequent monitoring, the outcomes can be grouped into three major categories or major outcomes. So we have the work performance, employee relations, and then the most important for me is health, safety, and the comfort of the occupants. So here's a visual of what is the, I'd say, what are the good things that come out of doing this? So you'll see in work performance, you have increases in productivity, quality, consistency of work. And then because they're feeling better, you're also having less absenteeism. So there's less injuries, they're not as tired and so on. And then because less people are going away, calling in sick, or even quitting, your training requirements begin to decrease because there's less of a turnover in workers. So that's some cost savings there. And then because they're feeling good and they're doing their work and everything's going well, obviously morale will increase between employees, and then you'll have a better relationship between the employee and the employer as a result of increased job satisfaction. So for example, let's say when we go to a site and we do traditional indoor air quality assessments, a lot of the times people already know what that is. So we'll have occupants of the space asking like, oh, what are you doing? Are you assessing the indoor air quality? And then I respond, yeah, I am. And then they kind of chuckle and they're like, oh, that's awesome. Is it good in here? And I say, yes, yeah, it's pretty good. It's not that bad, and so on. But now, if we were to introduce another aspect to those annual assessments, so now we'd be assessing the physical environment, they'd see that their employer is stepping out of the box and trying something new and looking at their safety, their comfort, and their whole like environment as a whole, which is nice, and they should appreciate that, I hope. But I would appreciate that. And then because of all that, all the assessments and the outcomes of these assessments you get in terms of health and safety and their comfort, you have optimal job demands. The tasks are designed properly according to what their requirements are in the guidelines. So like, let's say they're drafting, the light that's required and the type of light that's available for them is appropriate and it's adjustable. So not everybody's the same. So everyone needs it to fit them rather than having to fit the worker to the task or the workstation or the workspace. It's more difficult to fit Lisa and myself to something, or, you know, let's say it's Anita. If you want to fit Anita to her workstation, it's hard to change what Anita is, or it's hard to change what I am, and it's hard to change what Lisa is, but it's easier to change what a workstation looks like and how it functions. So in doing that, we all know and we all hear all the time that doing ergonomic assessments reduces musculoskeletal injury risk, which is, you know, that's the main goal, obviously. But combining lighting assessments and noise reduces that risk even more. And having that risk decreased and the employees feeling better, their stress occurrence also decreases. And then, you know, obviously when you're stressed out, you get a lot of headaches and stuff like that. So that decreases. But being in good working postures and performing the work appropriately also decreases your headache occurrences. So I've mentioned ergonomics, and I provide a definition here as to what ergonomics is. It's a pretty wordy definition, but pretty much what it is you're matching the jobs, the tasks, the products, the systems to the workers. So you're not matching the worker to those jobs. And in doing so, it creates an optimal physical and mental environment for the worker to perform their work and stay healthy and comfortable. And then how you apply ergonomics in a indoor environment is pretty much you look at the design and the organizations of the jobs and the tasks office workers perform. So that's one thing you consider, as Lisa showed in the third slide, that diagram. You also consider the layout of the space, not just the type of concept your office is, an open concept, cubicles, but also the direction of flow. Where do people walk? Where do people spend a lot of time? That sort of thing. Where does it need to be more flexible? Like, let's say it's a space where multiple workers come and collaborate, like a collaborative space. That needs to be the most flexible because you have so many different workers coming into that space. And other things you want to consider is equipment, like keyboards, monitors, input devices, and the furniture, the layout of the equipment, the positioning of light sources, and even the equipment on the workstation and around the workstation. So putting these things in optimal positions will obviously increase productivity, and it'll make them more comfortable because, let's say, for example, they use their mouse and it's in the inappropriate position. They may be reaching too far or too far forward or too far out wide to the side, and that could cause musculoskeletal injuries and increased stress in those the joints that are being used and the tissues being used. And you also have office environmental noise. So like in an open concept office, it might be too loud, but that noise could be decreased just by the design of the office space. Rather than assessing the noise itself, you can also assess the office space itself. And then one is very technical, is software and human computer interfaces. It's pretty much just like the type of programs you use. If they're not user friendly, it's not really that great to use it for your whole shift because it's more taxing on the worker and makes them work slower. Whereas if it's a user-friendly software, which most softwares aren't, it's not that great, or it is better. So now let's move on to noise. So in a non-industrial indoor environment, you're going to have noise, but it's not going to be from specific sources. Like if it was in an industrial environment where you have airplanes and you're working on airplanes and you're doing maintenance work there, then the work is from the maintenance, the noise is from the maintenance work. Or if you're in a steel mill, that the noise is from the steel making process. Whereas in an office environment, you have basically four major sources. So that's external noise, and that's caused by transit systems, construction, similar things like that are occurring outside of your space. So for example, at our office, we are right beside the airport, so our external noise would be aircraft noise. And then a building system noise, that's pretty much caused by the building's components. So your heating and air conditioning systems, electrical systems, plumbing, elevators, and other building supports. So for example, if you're walking by an electrical room, you'll hear a buzzing sound, like it's like bzzz. And let's say your workstation's positioned in that area, that'll be bothersome to that worker because they're being exposed to it for quite a long time, and it's more of an irritant and an annoyance than a health issue, and I'll explain that a little later. And then you'll also have office equipment noise. So that's caused by telephones, printers, copiers, your keyboard, mouses. And then let's say you have a lab in your office, like we do at T. Harris. We have this thing called a capture hood. So when we assess asbestos samples, we turn that on so that it's captured, like it's basically our local exhaust ventilation. It's capturing the fibers so that they don't become airborne and we don't inhale them. And that thing is freakishly loud if you have it on at the right setting. And my desk is obviously right across from the lab, so that's noise that I'm exposed to, and it could be annoying and bothersome. So there might be not just removing that source, but there might be different work application methods that could be applied when a noise assessment is conducted so that you can reduce exposures and noise levels throughout the office space. And then lastly, you have occupant noise. So that's caused by the conversations and activities and movements of the office occupants. So like you see in this video, these people are bouncing back and forth, talking to each other, and that's creating a lot of noise, especially if the building materials or the design of the space is inappropriate. One of the main things is speech privacy and the noise intrusion. So that's the two top complaints in an open office plan. And that's pretty much like you can't have a private conversation with somebody or over the phone because somebody else can hear it because the noise will be able to travel, and noise is pretty common in that space. And then the noise intrusion is because noise is so common, you're not able to sit there and focus and be in your zone because you're also hearing Johnny and Debbie talking, especially if let's say you share a small office space and you have multiple people inside, you'll be bothered by that quite a bit because you can't do anything about it. Oh, I'm frozen. Oops. One second here.
Sorry guys, it just seems that Jordan, his computer has frozen. Lisa, are you able to move the next slide?
Oh, yes, if Jordan wanted to chime in here.
Jordan, are you still able to talk?
I guess not. Let's see. I can try to take over his slides if it is taking him a while to connect, but maybe we should wait a little to see if he reconnects.
Can you hear me?
Yes.
Yeah. Oh, great. Okay. Sorry, everyone. Let's go back. Okay. Let's share this. Okay. So, pretty much I explained this all and then I got cut off. But yeah, we have the four different sources of noise inside of the office environment or the non-industrial indoor environment. And then the types of noise levels that should be observed or that should be present should support the tasks that are being performed. So let's say there needs to be a lot of communication. They need to have appropriate levels of speech, so they shouldn't be yelling at each other. But at the same time, somebody sitting across the office shouldn't be hearing them, and they should have the freedom to talk without distracting others. Additionally, you need to have a comfortable background level of noise. So I've been in some places where they consistently have background white noise on, and let's say that's too loud. Now you're going to be talking louder, and the average sound is going to increase, and additionally, the peak sound levels will increase throughout a normal day. And that's just on a normal day. But imagine if it was a busy day or a day where something goes wrong and people start to panic a little bit and talk louder and more. And also, the sound needs to be consistent from one location to another. Let's say it's an open office plan. the sound should be consistent throughout, so you don't have people yelling and screaming on one side and others, it's super quiet for them, but it's not quiet because they hear other people yelling. So that sort of thing. And then there's no specific level like health limits for indoor environments that are not industrial really. But you do have the occupational exposure limit. So that's pretty much a limit that's enforced by, for example, the government of Ontario. And that's to protect against noise-induced hearing loss and then other noise-related health concerns. So you can have that I'll mention a little bit later. And the ones that are above that, so in this table, you have industrial control room, call centers, and that sort of thing. Those are from the CSA ergonomic standard. And they're just guidelines for what the rough sound level should be in that area for the tasks that will be performed in those areas. So in a private office, you can have it at 45 because it's just you talking in there. So your voice is not bothering yourself. Whereas in a executive office or in a conference room, you need it to be a little bit lower because conversations are taking place, focuses, and you don't want external noises to be intruding there. And then the benefits of assessing noise. So like I mentioned before, a lot of people complain about noise, and the numerous studies have shown that noise is one of the most commonly cited and significant impediments in employee satisfaction and productivity. So it's not just ergonomics, but if they're not feeling good, now imagine if they can't concentrate, they're going to be pretty annoyed and pretty upset with, or pretty stressed out. And then because they're stressed out, they're also going to reduce their productivity because when you're stressed, you kind of just sit there and don't want to do anything. But at the same time, you might also work better under stress. So it's not the same for everyone, but you want to make it so that it applies for most people. And then there's obviously a downside of noise in indoor environments. Like noise is always there, but when it's too noisy for the task or too noisy in general, you'll have an increased risk of cardiovascular disease in these environments. So research has shown that exposure in a noisy environment can increase the exposed individual's blood pressure. Sometimes you do feel that. Let's say you go to a concert, you feel a little like hyped up after because of the amount of noise there, and that's not something that you're hyped up because you listen to some singer that you like or a band, but you're hyped up just because that's a physiological response to the noise. And then also, like I've been saying, is they just feel distracted or annoyed by others more often when it's too noisy. And then that takes away from their focus and reduces their performance. And when you're not being able to maintain focus and perform at the level that you're required to, you get stressed out because you feel like you're falling behind. And that's something that you want to mitigate with a noise assessment. And then the last one of the three is lighting. So like I said, if we really wanted to, we can encompass all the physical environment pollutants into one, but we want to make sure that every single one has a focus, and that when you think of ergonomics, you don't just think of ergonomics like chairs and all that stuff, but you also think of all the other components, because there's even vibration that could be included. And like Lisa mentioned, there's psychosocial diseases that can arise from poor indoor environmental quality. So kind of looking at all of those together, you protect and you ensure that it's a good environment. So in a lighting assessment, light is always there. Even when light is not there, technically a lighting assessment is still required because that might be that there's not enough light. So during a lighting assessment, what we look at are the characteristics of the light source. So pretty much it's natural versus artificial. So lights versus sunlight, the direction and the location of it. Also, if it's indirect or direct, if it's coming right at you or if it's being reflected off of the surface. And the color of the light. Is it those really white lights, like the ones that you see when you're driving at nighttime and the person behind you has like extremely white lights and you can't see anything? Or is it a nicer soft yellow is required for that task? You'd be looking at the luminance level of the light, so how much light is there. And then the presence of glare or shadows. Like I showed in that video before, there were shadows and glare. So we'd be measuring luminance levels, pretty much how much light is coming off of that surface. And then we look at something that's not light directly, but the tasks that are being performed. So let's say you're drafting and we measure this amount of light. Oh, now is that light appropriate for the task that is being performed? Yes or no, that sort of thing. And it's flexibility of the light sources for the occupants. So we always want to see flexibility because not everybody's the same and not everything fits everybody's needs. Like one size fits all is not true. And that's the same thing applies for the indoor environment and its pollutants. So to control for them, you have to come up with flexible controls so that it suits everybody and everybody stays comfortable, productive, and healthy. And your outcome of inadequate lighting. So you're pretty much watching this guy's clip here. You get the gist of it. You're working in the dark or you're working in crappy lighting and you're looking at a screen and the screen's flickering. You start to not be able to see the information properly because you just can't. It's either too bright or not bright enough. Your eyes begin to strain because you're squinting, or they constantly need to be refocused because of the flickering. And then because of this, you develop stress. You're also, one of the responses of your body is to have a headache in these circumstances. So when you have inadequate lighting, it could be too much or too little. You can develop a headache either way. And having too much light coming off of shiny surfaces, for example, like a tabletop or a finishing on a wall, can annoy people. They're not looking directly at it, but it's in the corner of their eye. It might be a little bit bothersome. And then the last one is neck pain. As you saw, like when I was squinting, I was moving forward. So that's another thing that we would look at. And now it's Lisa's turn. Oh, I might be frozen again. Am I frozen again? Okay, let's restart this.
Lisa, are you able to take control and switch the slides? Okay, it seems that both of them are actually frozen. Just give them one moment to rejoin the presentation. Sorry about that. Okay, there we go. We have them back.
Okay. Yeah, sorry that. Is Jordan back?
I see that he's back, but his screen is blank. I don't see him.
I'm back.
I can pull up the slides. Okay, perfect. Sorry about that. Lots of technical difficulties today, but moving on to our last topic of the day, and that is looking at tracer gas in indoor environmental quality and how we can apply it in these settings. So to start off, a tracer gas is essentially an idealized substance used to tag volumes of air so as to be able to infer their bulk movements. In other words, a tracer gas offers us a way to visualize something that is otherwise invisible and track the air. In tracer gas testing, we release a tracer gas into the air and use it to evaluate air movement over time. So there are 5 main ideal properties of a tracer gas. So 1, a tracer gas should be safe. It should be non-flammable, non-toxic, non-allergenic, in that it doesn't harm people when it is being released. It should be non-reactive so that it doesn't react with the process that is being evaluated physically or chemically. It should be insensible, so it shouldn't affect the airflow of the process being studied. It should be unique, so it should be easily distinguishable from background air. And lastly, it should be measurable. So we should be able to quantify and track the tracer gas that we are being released. So when selecting a tracer gas, it's important to weigh out the pros and cons of each. We already discussed the ideal properties of a tracer gas, and it seems easy enough, like there are 4 properties, but unfortunately, it's really hard to find a gas that meets all 5 criteria. Sorry, there were 5 criteria, but it's hard to find a gas that meets all 5 criteria. And so going through some examples of tracer gases, we have helium, sulfur hexafluoride, and nitrous oxide, and these are all unique gases that are distinguishable from the background air. But for example, nitrous oxide has an occupational exposure limit of 25 ppm. So exposures above this level may cause health effects. And so it's not necessarily the safest tracer gas. Sulfur hexafluoride is poorly degraded and can lead to greenhouse gases. So in that sense, we don't like to use it very often either. Carbon dioxide is the one that us at T. Harris like to use because it's relatively safe to use. And it's easy to measure, although it's important to acknowledge that it is already present in our air already. And so evidently there are advantages and disadvantages of each gas. So therefore, when we perform a tracer gas assessment, we like to weigh out the pros and cons and choose the appropriate gas for the specific application. And tracer gas testing has a diverse range of applications. So it can be applied in healthcare settings, in offices, schools, manufacturing facilities, warehouses, and essentially anywhere or within any process that depends on air movement. So going through some examples of applications that we can use tracer gas testing in healthcare, we may use tracer gas testing to answer the questions: is enough fresh, clean air being circulated in the hospital? Is the ventilation adequately keeping contaminants out of the operating room? And these 2 questions are really important for infection prevention and control, and to keep both patients and workers safe and healthy within a healthcare setting. There are also many applications of tracer gas testing in industrial settings. So, for example, many facilities have welders. And as many of you are aware, welding fumes can be hazardous and may require local exhaust ventilation. So for some local exhaust ventilation hoods, there are ranges or target ventilation values that must be met for the ventilation to be performing up to a specification in order to adequately protect the workers. So we can use local exhaust ventilation to ask the question or answer the question if the local exhaust ventilation is performing up to these specifications to control the levels of hazardous chemicals that workers are being exposed to. In terms of education, institutes or offices, we might ask the question if these offices or classrooms have enough fresh air for occupants to be comfortable and productive. And we may also use tracer gas testing to answer the question, given the current ventilation system, what is the maximum capacity of occupants in a given space? And this is particularly relevant to offices right now as people are returning to work or to school following the COVID-19 pandemic, and people are wondering how many people I can have in a room for it to be safe. On the topic of schools, the pandemic has brought light to the importance of ventilation in classrooms, and governments such as the BC government are committing more money into improving air quality for students and teachers. It was recently announced by the BC government that they are providing nearly $50 million to upgrade the ventilation system in schools throughout the province. So looking at this, one way that we may apply tracer gas testing is to identify the schools with ventilation that needs to be improved. As well, we can use tracer gas testing to quantify and confirm that improvements of the ventilation system have been made after we make the improvements. And lastly, another recent application of tracer gas testing is that it has been used to determine if the ventilation is adequately protecting occupants against COVID-19 infection. So in a study, it was shown that 6 air changes per hour is the ventilation rate needed to reduce the relative risk of COVID-19 infection by 95%. And so we can use tracer gas testing to determine the air changes per hour and then compare it to 6 air changes per hour here. And so why is tracer gas testing important? Well, first of all, there are legal requirements. So in Ontario specifically, under the Ontario Occupational Health and Safety Act, under the General Duty Clause, the employer is required to take every precaution reasonable in the circumstances for the protection of a worker. And that includes things like having proper indoor air quality for them. And more specifically, under OREG 833, control of exposure to biological or chemical agents, there are occupational exposure limits that employers are explicitly required to maintain so that the workers' exposures to these chemicals are below the occupational exposure limit. And so tracer gas testing can be used to help assess if the ventilation is performing adequately to help keep levels of these contaminants low. And of course, we all want to strive for the best. So we may perform tracer gas testing to look at indoor air quality as a best practice and compare it to best practice standards such as the ASHRAE 62.1. And so when we do tracer gas testing, essentially what we're doing is measuring the air exchange rate, which is the number of times that outdoor air replaces indoor air within a space every hour. So if we have 6 air changes per hour, it means the indoor air is being replaced 6 times every hour. And here are typical air exchange rates in different settings. And we use the standard ASTM E741-11 in our tracer gas testing. And just to go over how we use a tracer gas to measure air exchange rates, it's also useful to have a general idea of what the ventilation system is doing with the air. And so the outdoor air comes in and it's brought into an occupied space. The HVAC system also takes up that air and returns it back to the system. And this air can do one of 2 things. It can either be brought back outside, or it can be brought back into the system and to be recirculated. So when we measure air exchange rates, the first thing we do is to turn off the ventilation system, and this stops the air movement within this occupied space. Next, we disperse tracer gas to elevate its concentration in the space. And because the ventilation is turned off, none of the gas is leaving this area, and we record the elevated concentration. So here is a video of Jordan conducting a tracer gas test in our office. And here we are using carbon dioxide as the tracer gas, and it's being released from dry ice in this cooler as the dry ice sublimates. And Jordan here is just using a blower to disperse the carbon dioxide and to elevate its concentration within this area. And after we elevate the concentration, we turn the ventilation system back on and air movement is restored. And because air movement is restored, some of the tracer gas escapes, goes back into the ventilation system, and some of it is exhausted and leaves the building. And so as this occurs over time, the concentration within this occupied space will decrease as new outdoor air is being brought into the space, and we can use an instrument to track this decrease in concentration. And so we can take our findings and plot the measurements. So here is an elevation at that peak. We turn the ventilation back on, and here is the decay that I was talking about. And we may repeat it multiple times and with different settings on the HVAC system. And we can, from this decay rate, determine the air changes per hour and then compare it to different standards to determine whether the ventilation system is performing poorly, performing adequately, or doing exceptional. And so that brings us to the end of our presentation. If you have any questions, please feel free to put them in the chat or to raise your hand and I can unmute you. But thank you so much for joining us today in our webinar, and we really hope that you learned something. And if you have any questions about indoor environmental quality, please feel free to reach out. Could you please show the pyramid of the air changes per hour? Yes. Were we talking about this pyramid? Okay. This comes from the American Industrial Hygiene Association, and in the slides that will be sent out after this presentation, the last slide has a references slide, and there's a link to kind of a more in-depth explanation of this pyramid and how it was derived as well in that link. Thoughts on moving from MERV 8 to MERV 13 as recommended by ASHRAE? So I guess a MERV 13 has a higher filtering capacity or ability to filter smaller things than a MERV 8. So, but that also depends on the capacity of the HVAC system, because not every, as we increase the filtering abilities, there's more pressure on the HVAC system, and so not every system is necessarily designed to handle an increase in terms of MERV. So I think if the system is able to handle it, then of course we want to follow the best practice recommendation by ASHRAE. But if it's unable to, I think it's important to maybe assess upgrading the HVAC system, which may be a large cost, and to see if that's feasible, or come up with other ways to improve indoor air quality.
Yeah, and I will just butt in here. When we would calculate your theoretical air changes per hour, we would use the efficiency of the filter. So if you do have a MERV 13, you'd have the ability to have more air changes per hour without introducing more fresh air, because the air is being filtered better or more efficiently. And then, like what Lisa was saying, if you can't add or adjust your current HVAC system, we can also introduce the use of portable air handling units that can have more efficient filters than your main unit is equipped with. So then that would help, because now you have increased efficiency in the portable units while still maintaining the addition of fresh air and circulation efficiency of the big unit itself.
And another question we had was, as people return to work, what would you recommend to property managers would be the most prudent aspect of an IEQ to perform first? Jordan, if you want to chime in.
Oh, tricky question. It depends. Like you can do, I'd say the first thing that you would want to do before people do return to work would be to conduct a ventilation assessment to make sure that one, your system is working properly, but at the same time that you're providing sufficient protection against one, you have COVID, but also, the SARS-CoV-2 virus, but then you also have your indoor air pollutants itself. Since the space wasn't occupied and maybe the ventilation system wasn't operating as it usually would, you have the potential for indoor air contaminants to accumulate in the space. So that'd be the first one. And then the second one I would do would be ergonomics, just to reassess the workspaces because they might have changed based off of protocols and procedures due to COVID and infection prevention. Maybe you space people out and stuff like that. They might be in the wrong, their workstation might be different than how it used to be. So you want to reassess that. And then after that, you would follow with the next one, I'd say would be lighting. And then noise when people are actually in the office. And then, yeah, your traditional IAQ assessments can be scattered throughout there whenever it's possible, but the best would be when people are in the space so that you get a true representation of what the indoor air quality is like when people are there, and also how the people are working when they're present. So that would work for lighting and noise itself. So hopefully that helps.
For people continuing to work at home, is it possible to perform a virtual ergonomics assessment? Yes, and Jordan actually performs those, so I'm sure he has more details for that, but it is possible. Yes.
Yeah, very possible. I've done it before, and it's kind of neat because you spend time talking to them and walking them through how to conduct the assessment. Whereas if it was in person, pretty much I'd be doing the whole assessment myself, and they're just there. But virtually, it's kind of like a 2-for-1. You get education, so the worker or the person being affected gets educated on what ergonomics is and what I'm looking for, and at the same time, they're also getting their workstation assessed. And then in the future, let's say they want to make changes to their workstation, they now have some sort of knowledge of what to look for, at least in terms of a good workstation setup design, what should be included, and what increases and decreases risk in terms of ergonomics itself.
Yeah, if anyone has any more questions, again, please feel free to put up your hand. We can unmute you, or you can put them in the chat. But very good questions so far.
Yes, and we appreciate all of you attending, as this is probably most of your lunchtime, and we took up all of it chatting away. But if you have to go, by all means, you're free to go. You'll get a copy of the presentation as well as a recording of the webinar, just in case you came late or you wanted to check back on something. Or we have that for you so you can review, of course.
Mm-hmm. Okay, well, if there are no more questions, thank you again. And we hope that you have a good rest of your day and that we were able to teach you something.